Okay, just talking about the last example real quick before we move on to any other examples. The example I went over for the similarity transformation included a translation and then a dilation. That's the only example I went over. You know how to do, or should know how to do, each of the transformations, translations, reflections, rotations, and dilations. So you should be able to do any combination or composition of transformations. For example, a dilation followed by a reflection, a rotation followed by a dilation, or any other combination. Now let's look at kind of working backwards here, being given the graph and then trying to figure out a composition of transformations that maps a pre-image to the image. For example, on number 4, here's your pre-image, triangle LMN, and then here's the image, triangle L prime, M prime, N prime. And you want to figure out a similarity transformation. So since it's a similarity transformation, here's one thing that you should know for sure. It has to include a dilation. There's no way of getting around, even if you do any multiple combination of transformations with a rotation, a reflection, or a translation, you wouldn't be able to come up with the image without using a dilation. And there's not just one answer here. So maybe what you're thinking about, if you pause the video real quick and think about a composition of transformations that you can use from triangle LMN to L prime, M prime, N prime, and what we go over might be slightly different, and you could be correct as well. But as I mentioned, you have to use a dilation. So you can compare side lengths. For example, NM is twice the length of N prime, M prime, and so on. NL is twice the length of N prime, L prime. So you could say a dilation with a scale factor. So you have to include the scale factor. You can't just say dilation, because a dilation could be a reduction, which it is in this case, or an enlargement. And if you don't specify what the scale factor is, it could be either of those. But the scale factor is 1/2 or 0.5, because we're comparing the image to a pre-image. Okay, it's not a scale factor of 2, because you don't start with this is the pre-image and then enlargement. You actually reduce it by a scale factor of 1/2. And then you might just need to figure out the coordinates of like N prime, L prime after the dilation. But a dilation first with the scale factor of 1/2. And then to come up with N prime, M prime, L prime, you have to take that dilated figure and then move it 4 units to the right and 1 unit down. And then the way that I described it is using ordered pair notation. You could describe it in words like I just did and write out what I said, or you can use ordered pair notation. You could use vector notation. Okay. You could also use a component format as well. But I didn't label this because this is just N prime, M prime, L prime. I don't want to use double prime because that would be after the second transformation. So you can't just dilate, you also have to translate. Maybe you thought about something else. You can get really fancy, include rotations in there, possibly reflections. But if you want to describe the transformation in just 2 transformations, it would be a dilation followed by a translation. You could possibly do a translation followed by a dilation, but the scale factor definitely should be 1/2.